Let's talk about why cost deterministic Plutus is such a beautiful thing. Ready? Let's go. There is a huge difference between Cardano's extended unspent transaction output model and Ethereum's account balance model. And today we're going to discuss why it is so good to be on this side of the fence. To help explain the difference between Cardano and Ethereum, we've procured some more CCTV footage at great cost. This CCTV footage is overlooking the Ethereum car lot. Here at the Ethereum car lot, we've got an Ethereum user, a prospective Ethereum user, and we've got Vitalik. No, wait. That's not Vitalik. That's some other guy. Vitalik looks more like this. That's more of a Vitalik with the neck. Okay. So the Ethereum, this is a prospective user. So the prospective user comes to the Ethereum car lot and he's like, hey, I am interested in using the Ethereum car. I want to get the Ethereum car and use it to travel to places. And one of the most important things about traveling to a place is that I must know how much gas is necessary to get to that location. Will I have enough gas to actually get to my location? Because running out of gas completely sucks. And of course, Vitalik says, well, actually, one of the things about the Ethereum car is that we can't really calculate how much gas it takes to get anywhere. It's kind of like, sometimes it's kind of dependent on what all the other cars in the information grid are doing. So we actually have no idea sometimes how much gas it's going to take for you to get to your destination. So the user is like, so people are buying this car and sometimes it's like impossible to calculate how much gas it's going to take to get to the destination. And they just run out of gas, like they don't get to their destination and they're just stuck. Well, in those cases, we just kind of suggest that you use more gas. And here is the response of the user. Any kind of reasonable user, this would be the response to that. This paradigm makes no sense whatsoever. This is a big deal. This is not a small thing. Cardano is deterministic as to costs, whereas Ethereum is not. In Cardano, you can calculate locally in your own wallet ahead of time how much something's going to cost. In Ethereum, you can't do that. You can use some kind of estimator, some kind of calculator that'll estimate gas fees for you. Maybe it's right, maybe it's wrong, but it is not too different from having a car and having like a full tank of gas and not knowing if that tank is going to get you to your destination or not, because you don't know the exact miles per gallon of this Ethereum car. Not the case in Cardano. In Cardano, you know exactly how much gas it's going to take to get to your destination. So it's important to understand exactly how this works. Luckily, Sebastien, formerly of Emergo, now of DC Spark, along with Nicholas Arqueros and Robert Kornacki, who was super helpful back in the old days on the Cardano forums whenever you had a question about Plutus, Sebastien has put out a video which is like one of the best explanations I've ever seen of why Cardano can be deterministic as to cost. It's also just sort of a great explanation of how certain things work in Plutus. There's certain elements in Plutus, certain words you're going to hear thrown around a lot, and we're not going to get too complicated. You're going to completely understand everything we're going to go through, but this is going to make you like slightly conversant, right? Like cocktail party conversant in what some of these different elements in Plutus do, right? You're not going to be able to code any Plutus smart contracts in Plutus at least. You probably could in Marlowe, but not in Plutus based on what we're going to talk about today. We're not going to get that level of detail because that's what the Plutus Pioneers program does. And it's, going to be like 10 hours. We're going to spend a short amount of time. We're going to go through the basics, just make you conversant. Okay, we're going to break this down into little manageable pieces. And once you understand each of those little pieces, you'll understand how all this comes together and how this all works to make Cardano deterministic as to costs. So first, we need to understand how costs are calculated in Cardano. So the first element is the language being used, right? On launch of Alonzo, we're going to have Plutus version 1. But, Cardano is the kind of project that always wants to evolve. So someday we'll probably have Plutus version 2. So you need to know what language you're using to determine the costs involved. Then we have a cost model. So the cost model converts the terms used in, right, like in the language, like Plutus version 1 on Alonzo launch. So it'll convert the terms used in Plutus to execution units, abbreviated here as X units, which consist of a pair of two different types of information, the memory footprint of whatever's going on, and the number of computational steps involved. Those execution units are then mapped to an exact ADA cost so that the transaction fees you're paying are denominated in ADA, which you understand, unlike these execution units for most people. So next we have to ask, okay, that's great, but how are the execution units calculated? How do we convert the terms in the language to these execution units? So there are two steps to determination of transaction failure, basically, in Cardano. So just because it's deterministic as to how much transaction is going to cost you doesn't mean the transaction can't fail. Right? If the script's involved, like if you can write a smart contract that will fail every single time, right? The code just doesn't work. It fails. It doesn't do what it's supposed to do, and the transaction fails because the code is messed up. So this is a distinct possibility. No matter even if the cost of the transaction is deterministic, if we can figure out beforehand what the cost of the transaction will be. So there's two steps to making this determination. There's a phase 1 and a phase 2. Phase 1 is just basic transaction validation. In phase 1, all costs of the transaction are determined and no collateral is consumed. Okay, brand new word, collateral. What is collateral? We haven't talked about collateral in Cardano before. What is collateral? We're gonna get to it in a second. Just give me 1 second. So phase 2 is smart contract execution. And in phase 2, inputs can be consumed as collateral. So what is collateral? We don't want people to spam the network with transactions that are going to fail and not have to pay a cost for that. So we have to have some kind of cost so that the network can't get all jammed up in an attack with spam transactions that are going to fail anyways. So there's got to be something consumed even when a transaction fails. Luckily, and that's going to be ADA. It won't be tokens. Like you cannot, the obvious attack here, given what I just said, would be to mint your own tokens and then use those tokens to, pay the failed transaction collateral. Can't do that. It's got to be ADA. Can't be a token. So there's a percentage parameter to this collateral to determine how much the collateral needs to be. And it's yet to be determined, but Sebastian's guess is that the percentage will be 100%, which would put the collateral amount for each transaction equivalent to the transaction cost. But, obviously it could be adjusted and it hasn't been determined yet. So this sounds kind of scary, right? We're talking about consuming the inputs to a failed transaction as collateral. But it's actually not that big a deal. It's not that big a deal or anything scary at all, since costs are deterministic. You're going to know ahead of time how much it's going to cost. So this won't be an unknown amount that surprises you. It'll only surprise you if you wrote a bad smart contract and everything doesn't work and then the transaction is going to fail. Unfortunately, there's no way to solve that problem. If you write a smart contract that doesn't work, the transaction needs to fail. In fact, you want it to fail. You don't want the blockchain to run transactions that don't match normal logic. Okay, here's the part that is going to make you cocktail party conversant about how Cardano can be deterministic as to costs. and Ethereum is not. So there are 4 elements in Plutus you need to know about, and we're going to make them simple. There's a redeemer, a witness, a datum, and a context. So the redeemer is just arbitrary data needed to spend from an address. And it can have like sort of 4 types, 4 flags attached to it. One is spend. This is just a normal unspent transaction output, like you're sending ADA to some address. Mint, this is like when you mint tokens. Cert, which are certificates with script credentials, as in when you delegate your stake, it's a cert. And reward, which are reward withdrawals from script addresses. So just 4 types of redeemers, right? 4 different things that you can do, 4 different ways you can spend from an address. And then you got the witness. So the witness maps which redeemer is used for which script. And remember, a script is just like a small computer program that's being run by another computer program. So nothing magical about it. A script is just, you can think of it as just a little computer program being run by another computer program. So the witness maps which of those 4 different types of redeemer is used for which script. The datum stores the smart contract state for an unspent transaction output entry. So here's where we differ strongly from Ethereum. In Ethereum, the scripts interact with a global state system. In Ethereum, the scripts have access to what everything else is doing in Ethereum. It's global state. The scripts can see everything if necessary. And this is why the analogy is to a car whose miles per gallon can't be determined, because sometimes its miles per gallon gets messed up by what all the other cars in the transportation grid are doing. I think earlier I accidentally said information grid, but I meant transportation grid. So in Cardano, the datum just stores the smart contract state, right? The scripts can look at the inputs to that transaction and the local things that are going on with that smart contract. They don't look at all the other smart contracts on the Cardano network or all the other addresses or what's going on, the balances of other addresses throughout the network. They just look at they just look at the local things that are local to that smart contract, which is more like a car that has an efficiency, a miles per gallon, an MPG, that is just dependent on that car, right? You put the gas in the car and the car is going to go so far on a full tank of gas. It's like a normal car, like the kind of car you'd buy, not like this Ethereum car, which is dependent on what the rest of the transportation grid is doing. So the datum stores the smart contract state. Then you've got context. Context is arbitrary data that Plutus scripts can parse, and it has 2 elements. Transaction info, which contains information about things like inputs, outputs, fees paid, and script purpose, which contains the redeemer flag. So the redeemer flag, again, remember that was the type, the spend, mint, cert, or reward. So that probably seemed like a lot, but don't worry. All you need to remember is that we have a redeemer, a witness, a datum, and a context. So when we're spending a UTXO entry and a smart contract is involved, here's the important part. You always have a redeemer, a context, and a datum. If the smart contract's not involved, and I'm oversimplifying here, but when a smart contract's not involved, you just have a redeemer and a context, not a datum. This makes sense, right? Because the datum stores the smart contract state. And if there's not a smart contract involved, you don't need the datum. So with the smart contract involved, we have a redeemer, a context, and a datum to spend a UTXO entry. Okay, that was the only hard part. You just need to understand we have a redeemer, a witness, a datum, and a context. Those are the only hard parts. If you understand those exist, now we can tie everything together here and we'll understand why Cardano can be deterministic as to costs. So in the transaction body, we're going to have this thing called the WitnessPPDataHash, and it's going to tie everything together for us. So these words and symbols over here are describing to you how the WitnessPPDataHash is created by this function. So don't get freaked out. This can be pretty simple. Just think of the function as this calculator, and we're going to punch a bunch of stuff into the calculator, and it's going to give us a result. And the way you write that in Haskell, in Plutus, which is a subset of Haskell, but the way you write that in both Plutus and Haskell is through typing. So we have these types of inputs, right? Different types of things you can put into the calculator. And we also have a type of thing the calculator is going to spit out. And that's what this little section over here with the arrows tells us. It basically tells us like, hey, we have a bunch of inputs, and then the last thing, the thing after the last arrow, is going to be the output. So these are all inputs, and this is the output. So the first input here in this function that produces our WitnessPPDataHash is the protocol parameters. Protocol parameters just takes into account that there will probably be future versions of the system, right? Cardano is always evolving, as we've already described, and there's going to be future versions of the system. So we need to know what version of the system the smart contract was written for, so that even if there's newer versions out in the future, we can still run the old smart contract because we know which version it was written for. So, if like the stuff from Ouroboros Chronos is incorporated into the system, but a smart contract was written before that, we can say like, hey, this is for the version of the system without Ouroboros Chronos, so don't try to do any of the Chronos stuff when you run this contract. Great. The next thing is the language. So we know that the language might evolve in the future. So this is going to tell us like, hey, was this written for Plutus version 1, Plutus version 2? What is this written for? So that's another input. Then we have another input, which is the redeemer, right? And, redeemer PTR, this is just a redeemer pointer, but basically we're going to have the redeemer and the execution units, right? So the redeemer is going to tell us like, is this like, are we spending here? Are we minting tokens? Is this a certificate, kind of like you use for stake delegation? Is this a reward withdrawal? What is this? And then the execution units we already described are the way we compute the memory footprint of whatever's going on and the number of computational steps involved. Next, we have the datum. We just described the datum stores the smart contract state. So this tells us what's going on in the smart contract. All those things together are inputs. We shove those in the calculator, the function, and what we get out is the WitnessPPDataHash, which is all the information we need to calculate the cost of the transaction. We've got some other things over here. So that's a part of the transaction body, but we have some other things over here like transaction inputs, transaction outputs, a bunch of things that are in that category of transaction info. But all these things together, this is everything we need to calculate the cost of the transaction locally in your wallet before you ever run it. This is why in Cardano, we know exactly how much gas it's going to take for your Cardano car to get you to your destination. In Ethereum, they don't have local state. They have global state. It can be gigantic, right? It can be gigantic, and you can't just put it all into a datum like you can the local state datum right over here. It's this input over here, right? We might hash it to make it more storage efficient, but it's still the datum. And because they have global state in Ethereum, they can't just put it in the datum and make it one of the inputs in a function like this. It has to be global state. So they can't do this. They can't do this in Ethereum. This is how we can be cost deterministic in Cardano and not in Ethereum. So the next time you're at a cocktail party and somebody asks you to explain why, one reason why Cardano is so much superior to Ethereum, you can explain to them, hey, in Cardano, we have this nice little hash, the WitnessPPDataHash, and it has as inputs the protocol parameters, the language, the redeemer, the execution units, the datum, and this all produces this along with some other transaction information that's included in the context. This all together allows us to calculate transaction costs, and it cannot be done in Ethereum because they have global state instead of local state, and that global state can't be wrapped up in a nice little datum like this. This is just my oversimplified guide on how to be conversant on this topic in cocktail parties. Guys like Sebastien have much deeper and more complete understandings of this, but I think this is enough to convince people that there's something going on in Cardano that is not going on in Ethereum, and I will talk to you tomorrow.